What's new with nuclear? Is the world ready? And should you be worried? This is Energy Matters with Claire
and Dan.
All right, thanks for joining today, Dan. I know this is one of your lovely, most favorite things to talk about. Nuclear. Lots of feelings about it. Let's talk about the background about why nuclear might be needed at first, right? We know that global energy demands are expected to increase by 50 to 100% by 2050, as stated by the Energy Information Administration. And industrial heat demands are projected to increase by 3.5 times by 2050, says Roland Berger. Is nuclear ready? Is nuclear going to be able to solve all of our problems?
And you're right. There's 1,000 different ways to enter this story. This episode's going to be a bit of history and a bit of current events. We're going to come back to nuclear again and again. But I guess if I were to frame the story, back in the old days, like 8 years ago, when we thought of the world as powered by coal, oil, natural gas, and nuclear, they were all what nerds call baseload technologies. They were more or less always on. So nuclear fit into that because it was baseload. You turn a reactor on and it's running. The world we're moving into is contested. There's people like me that believe it will be largely powered by renewables, which are so-called intermittent, meaning we have this thing called daytime and nighttime. So solar's not always on, and we have wind, which is not always on, and I guess it's never on, according to the president. And so nuclear has a different niche or a different market role in that old energy world and the new one. And the whole energy landscape is trying to sort it out. I try to sort it out from the science, the climate story. You're trying to sort it out from the business story. Others are looking at the risks. Others are looking at innovation. There's so many ways to think about it. We'll each today give a little bit of our kind of personal history, but knowing this is the first of many we'll be doing on nuclear over
Absolutely.
the seasons.
And I think as we start thinking about nuclear, just to start with, if you talk to your mom or my mom, they talk about Chernobyl and, of course, Hiroshima and all of the problems in 3 Mile Island. So how can we be so comfortable now that nuclear makes a lot of sense and nuclear is here to stay?
So I guess just a couple numbers, but the numbers are less important than the concept. So if you think about it, we had no nuclear power plants in operation in 1955. The first nuclear power plant installed anywhere in the world was in Shippingport, Pennsylvania. It was actually a reactor that was taken directly from a nuclear submarine. And it was small. It was a pilot plant. It operated for a number of years, quite successfully. And from that little pilot in the 50s, here we are in 2025. With the risks and the accidents you just mentioned, but there's about 420 nuclear reactors in the world. About 100 of them are in the U.S., and about 60 are in France. So
right, and 60 France is 75% powered by nuclear. Yeah?
Right, so I was just doing the number of plants, right? And so different countries, different amounts. The U.S. is about 20% powered by nuclear today. The world electricity is about 10%. So I'm just trying to set the landscape of from 1 in 1955 to 420 much, much bigger plants than that today. And for me, who does worry about the risk, the end of life, the high cost, every single one of those 420 plants will have to be retired before mid-century. Some plants are going to be retired at their scheduled lifetime. Others are going to get lifetime extensions with different costs. And there's a whole bunch of exciting new technologies that different groups are promoting. And it's into that interesting, complicated jumble that you and I kind of think about it from, I think, different perspectives.
Right. I think that's right. Because I think certainly the number of plants is important, but the gigawatts and looking at the gigawatts is important too. So the U.S., as I understand it, is looking to achieve on the order of 200 gigawatts of new nuclear build out by 2050. And why is that? Because nuclear energy provides stable baseload power, requiring low land use and transmission line build out, and has really high capacity factors. However, from the business side, it's all also very, very complicated because challenges with nuclear projects and new builds include cost overruns. For example, U.S. Vogtle plant cost $30 billion instead of $14 billion. There are really long lead times. supply chain delays, long and variable licensing timelines, and concerns with NIMBYism, or not in my backyard, and spent fuel, right? So there's a whole host of things which are making it really complicated for business people to nail down, yes, they do want to invest in nuclear.
Wait a second, Claire. You just said gigawatts, and I know we have some super energy nerds on, but we also have some people just kind of breaking in. What is a gigawatt? Why should we think in the units of gigawatts? What are we talking about here?
Yeah. Okay, so your typical light bulb is 75 watts, 50 watts, something like that, right? A typical solar project on your roof might be 10 kilowatts, or do that math for me, Dan.
10,000 watts.
10,000 watts, exactly, right? And so a gigawatt is what then? It
10
is,
to the ninth watts.
exactly.
So a billion watts is a gigawatt. And the way I think of it is not in kilowatts, megawatts, gigawatts. What I think of is when you drive by a coal plant on the side of the road, if you ever do that anymore, those plants are typically a gigawatt in size.
Or 1,000 megawatts, right?
Nuclear power plants come in two standard flavors historically: 1 gigawatt and 1.5 gigawatts. So 1,000 megawatts and 1,500 megawatts are the standard size plants we've been installing up to today, but there is something new on the horizon, and that's really going to be the focus today.
Absolutely, right. But from the business side, there have been really very few investors and utilities ready to take the risks in nuclear, right? The industry needs a strong demand side pull and customers willing to engage, both from industrial sectors and grid operators. So this is a very complex issue because it makes a lot of sense to install solar, right? We've had lots of episodes about that, but we're talking about 1 megawatt, 10 megawatt, maybe up to 100 megawatt projects. You're talking about 1,000 megawatt projects just to start with all of these additional risks like spent fuel, cost overruns, long lead times, all of the things we've said above. And the spent fuel is something that's huge. So Dan, tell me, how are we going to deal with this spent fuel issue?
So this is really getting complicated because every country has a different strategy. The U.S. strategy was to build one centralized facility in Nevada, and Nevada was chosen because the voters or the politicians were either paid off or saw this as a job creator. We decided this would be in a place called Yucca Mountain. Turned out it was not such a wise choice. The estimates for what the federal government spent on it range from $40 billion to several $100 billion, and it now is quite clear we're not going to use it because of worries about water intruding into what's supposed to be a secure site. You don't want uranium and plutonium getting into the water system. And irony of ironies, less than 100 miles away is a military site where we store military uranium, but of course we don't want to commingle commercial power plant uranium and that military stuff. So we don't have a solution in the United States. Everyone knows it. And that means that at the 100 nuclear power plants, and by the way, when I say 100 nuclear power plants in the US, they're at 67 sites. Some have several reactors. So we've got those 100 plants. Most of that fuel is now stored on site in big, oversized swimming pools in one of these things that when you say it, you slur your words. They're called spent fuel pools. That's the U.S. non-strategy. Germany, they wanted to put it in the ground in places that we could retrieve it later when there was a better solution. And then France and Japan said, well, that's valuable stuff. We should reprocess it back into new fuel. But we don't do that because if you reprocess it, you make bomb-grade plutonium. And so there are multiple challenges. So no one has a good solution. And just thank goodness we don't have too much plutonium and uranium just kind of wandering around in various hands. There's been times like the fall of the Soviet Union when maybe some of it got loose. There's always a science fiction or a James Bond movie when someone's stealing it on a train, taking it to various countries that are pariahs. So it is complicated. It's a long story.
Super complicated. Well, and there's some entities that are making good money on it. And Constellation being one of them. So Constellation has 21 nuclear power plants around the country. And, of course, they are saying nuclear is an essential part of carbon-free solutions because it's carbon-free, it's reliable balancing, which means it can be always on. It can grid balance and manage to ensure a stable and reliable energy system. It can support higher deployment of variable wind and solar generation without the need for backup capacity from fossil fuel generation. But Constellation is one of several companies that's done very, very well with nuclear power plants in the past many years. But not having a spent fuel solution, I mean, is this something that we as climate change people want to support or not, Dan?
So this is an area where environmentalists are as divided as we are divided left and right, because some people say, aligned a little bit with what you said, that nuclear is a nice complement to these intermittent renewables because it's always there and it's always available as long as the plants aren't in some crisis. Others on the kind of environmental left used to say, no, 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 that's not true because nuclear plants are very inflexible. Once you turn it on, it needs to operate at a certain level and just go and go. And that actually doesn't make space in the market for things that come and go like solar and wind. Now, there are some technical things we'll get to in later episodes about can you ramp your nuclear plant up and down? Could you make hydrogen when the demand for electricity is low? Could you boil water? Could you pump water? There's a lot of things you could do. We're not doing those today. But I think the big issue is, at least someone like me who has been studying nuclear, and I'm a professor of nuclear engineering for the last 20 years, where the plants we used to build were these big ones, these 1,000 megawatts, 1 gigawatt, 1.5 gigawatt. Now there's a new player on the horizon called small modular nuclear reactors, SMRs. And there are companies with names like NuScale and TerraPower, that is a Bill Gates company, Hitachi and GE, a whole bunch of these. And they want to build nuclear power plants that are much smaller. Instead of being 1 gigawatt, there are plans for plants as small as, call it 70 megawatts. There's actually one company that wants to build 5 megawatts. But leaving them aside, there are 70 to 300 megawatts is kind of the sweet spot of these reactors. And the argument that the industrialists, the billionaires who are backing these companies are making is interesting. It says when we mass produce technologies, big pens, calculators, solar panels, whatever it is, that the price comes down in a predictable way. Something we'll talk about in a later episode. So the nuclear community that used to build these unique one-off facilities are saying we want to get on the bandwagon of mass production. And not only get on the bandwagon of mass production, but when a small nuclear core has been partially used up, we want the company to come take it back to their central facility, take out the rods, put in new ones, and send it back. And so they're thinking about a new modular world, and it's got a lot of people, technologists, some economists, really excited that these SMRs, these small modular nukes, are going to be the wave of the future. I am very skeptical, but some people just love it.
Well, some people love it. And I think nuclear, especially these SMRs or small modular reactors, are one of the most discussed topics with everyone from startups to utilities to private equity.
No question.
My friend Brett Caddison at Teneo, who's the Senior Vice President of Energy and Climate Innovation, there's a whole research group that's doing a ton of work on SMRs. I mean, everything from financing models for new plants to partnering with fusion developers to innovative supporting technology like AI-enabled regulatory tools to accelerate development. All of these things are at play. And I think, one of the reasons these SMRs are so interesting is because you could ostensibly reduce capital costs and land use and lead times for nuclear. But that's really sort of the elephant in the room, is that new nuclear needs to overcome licensing and supply chain challenges to, come down the cost curve.
So for me, for me, the issue is something else. First of all, I don't think the land use is going to be any smaller, because if you take out a 1 gigawatt plant and replace it with 4 or 5 of these small plants, You're still going to space them out. And one company, New Scale, thinks they'll all be underground, so they'll be safer against terrorism and other kinds of issues. And they'll have something we'll talk about later called passive safety, basically where gravity provides the coolant if you have a problem. There's a lot of upside on paper. But to me, as a physicist, nuclear's problem in the past has not actually been the hardware. To me, nuclear's problem has been poor management, sensors, people in the control room reacting poorly to crises. That's exactly what happened both at Chernobyl and at Three Mile Island. It's a little different than what happened in Fukushima, where the earthquake tsunami overwhelmed the defenses that were built up at the plant, and we all watched those plants at Fukushima, one after the other, blow up as hydrogen built up in them. So for me, the challenge is that nuclear's issues is not technical, it's management. And I actually think that unless these small plants are super well managed and AI and other tools give us much better response to issues, that we're actually adding complication, not taking complication away by replacing one big plant with 4 or 5 smaller plants at the same site.
So that's a really interesting concept, but I think we're going to have to agree to disagree. I don't think anybody knows the answer for sure, but traditional nuclear plants usually require around 8 years for large reactors to be built. Some SMRs claim at least that their technologies can be constructed in 2 to 3 years or even less for microreactors. But tell me, Dan, have any small modular reactors actually been installed in the United States to date?
No, but
Right.
if you're a pro, so if you're a pro-nuclear person, you will say that is just a technicality because we have already built small modular nuclear reactors on aircraft carriers and icebreakers and a whole variety of kind of exotic features. And so the argument pro SMR, pro small modular reactor, is that we're not really doing that much new. We're just taking a technology we know how to manage, making it better and smarter, and deploying it for commercial power. But 0 today have been installed. And in fact, the initial plans made by the 2 leading companies, NuScale and TerraPower, have each changed dramatically as their initial contracts got pushed back and they look more and more expensive. We've already seen one of the companies have their initial agreement to build one in Utah get canceled because the cost went up by a factor of 3.
Yeah,
And
new scale project.
Right. And we've also seen the test reactor that was supposed to be built at Idaho National Labs, a super safe site, notably in a red state, but at a current national research site, get delayed for when it will happen. Now, if you're pro-nuclear, you're going to say these are just the teething, the learning bits early on. In my view, they're more problematic. And when we had the initial plans for even these gigawatt reactors, they also said 30 years ago they would be built in 2 or 3 years. Some of them have been built in a decade at 4 times over cost. And so I have yet to be convinced, but I'm hoping to be convinced that SMRs will be a different story. I am not yet convinced.
Right. I mean, and I think the big thing about that, you're talking about it from a sort of professor academic perspective, from a capital markets perspective. The capital cost for traditional nuclear still ranges from $8,000 a kilowatt to $14,000 a kilowatt.
Right, so way above solar. So let me ask you this. So I have been inside many nuclear power plants. How many have you been inside during operation?
2.
Okay. So nuclear plants have relatively few, relatively highly skilled operators in them.
Yeah.
And
wait, you mean Homer Simpson is in all of the nuclear power plants?
Well,
like my daughter would say?
I mean, Homer in the Glow is one aspect of the story. But nuclear plants to me are a little bit like police work in that they're operating, and when everything is normal, you can be, having your donuts and sitting 2 cop cars side by side or a couple operators in the room. But when the blank hits the fan, it is a crisis and you are scrambling. And I have video, classified and unclassified, of people in control rooms freaking out over things that looked after the fact like pretty small issues. And so I am hopeful, but I am skeptical, and I do not believe the current story that smaller, faster is going to be the case. One nuclear accident can ruin your whole day remains true whether it's one of these big gigawatt plants or one of these small modular plants. And we're going to get some people who absolutely hate that statement in their responses to this episode.
I hope so. Yeah, which is a good reminder that please come to us at energymatters.world with your comments and suggestions, because we care a lot about trying to make sure that we've got more folks of all different stripes and from all different sides of the spectrum coming and communicating with us, because really what we want to get to, neither of us need to be right. We want to get to the right answers with facts and with real data.
And let me contradict myself too. So when I say there's no SMRs installed in the United States, well, in Russia, they have already taken existing nuclear icebreakers and sent those ships to Russian Arctic ports, had the ships sit in the harbor, connect up the power lines of the city to the ship, and send power into the city. And so that is essentially the Russian version of what these nuclear companies, the GEs, Hitachis, Westinghouse, NuScale, TerraPowers, want to do. They want to use trucks or rail lines to move the nuclear cores back and forth. Russia's already doing it at small scale in the Arctic.
That's really interesting. I wonder what their costs are, because if we get back to the cost for just a second, for all of us who are geeks and not geeks, I mean, I think one of the things you have to think about when you think about energy broadly is the total cost of energy over time. As I've mentioned before, the Lazard levelized cost of energy comparison is really, really helpful, because it looks at, not just the installation cost, but the operations and maintenance cost of the system over time. And so at least in their June of 2025 report, and we'll put the link at energymatters.world, the, commercial industrial solar costs, less than $200 a megawatt hour, whereas, and sometimes as low as $80 a megawatt hour. US nuclear is easily $140 a megawatt hour, up to $220 a megawatt hour, and even higher.
And
right?
some of the, as you mentioned before, some of the plants that didn't go well are in the thousands per hour. So there are some huge numbers. So my lab just published a paper that we'll also put on the website in Nature magazine at the end of July of 2025, where we looked at the cost curves, the cost trajectories of US nuclear, French nuclear, Chinese nuclear, and South Korean nuclear. And what you find is that the most expensive plants of any of those locations are US plants built or commissioned over the last 30 years. The second most expensive are French plants, and French standardized their designs more than the US did. The least cost are Chinese plants, and just above that is Korean plants. And of course, the big footnote is both the US and France have some new, but mainly old plants, whereas South Korea and China have only new plants. And what we see in the data is that newer plants in the West are much more expensive than our simpler, older models. And so are we seeing in South Korea and China just the tip of the nuclear iceberg? They're just new plants, so they're cheaper. Or are we seeing actually lower cost? These small modular people will say, we're going to learn all the good lessons from China and South Korea. We're going to build smaller, modular, cheaper plants. There's other skeptics out there, I can name several, Amory Lovins, maybe myself and others, who are not yet convinced that they will remain cheap in South Korea and China as they build more and more plants. So we are talking hypotheticals, we're talking hopes and aspirations, hopes and dreams. We're going to find out, and it's going to make some people rich and some people bankrupt.
Well, and I mean, as important as that, it's a bunch of people could die, right? I mean, if you have a really bad accident here, this is a huge thing. You're not going to die from solar system. Right now,
so I've been pretty negative on nuclear so far.
Yes,
Would
you
I
have.
rather live next to a nuclear plant or a coal plant? I choose the nuclear plant every day of the week.
Right. That's always such a hard part of the conversation because when
Well, let's
people
be
say,
honest, right?
yeah, oh yeah, for sure. Right. When you talk about, well, I don't want solar, it's ugly, or I don't want offshore wind, it's ugly, then the response is, okay, so do you want to continue your coal-fired power plant? Because that's the only other solution. And that's sort of the tragedy of the commons and everything you talk about environmental science from the beginning of time. Like, I just want it to be the way it is. Well, the way it is isn't great.
So, I got up,
And
right. So I got up
yeah,
today and I went outside for my morning run, and we were having a spill of solar power, and it's called a sunny day.
right.
You have a spill of nuclear power and it's not called a sunny day, right?
Yeah.
So
No,
the
for sure.
risks now, they may be low probability, but they are high consequence.
Very high consequence. Yeah. Yeah. And I mean, I want to underscore this whole licensing of new technologies and developing supply chains and securing a customer base. Those are not for the weak of heart. Those are all really complicated things to do in the business world.
Yeah. So we know, for example, that, and again, this is going to sound anti nuclear, it's not meant to be. We know that solar and battery projects can come in, and many do come in under budget ahead of schedule. We do not have any examples of significant nuclear plants ever coming in under budget ahead of schedule in the West. That doesn't mean it won't happen in the future, but we have no track record of that because these plants are complicated and big, and that's one of the arguments that the small modular community is using. And I know someone's going to jump in and say, well, Dan, you're not talking about thorium plants and liquid metal and fast reactor. We'll get to those in later episodes, but just talking about these SMRs that are essentially scaled down conventional plants with some better sensors and better feedback, they are not novel except for they're smaller, although the US has not built a new nuclear plant essentially in 30 years until this long, long delayed Vogtle plant in Georgia. This is going to be a new step where hopefully new technology is going to help to some extent. I'm skeptical. If you're a proponent, you're not skeptical, you're optimistic. So the concerns, the battle lines, whatever you want to call it, are out there. There's a lot of promise. There's a lot of hype,
Well, there's
just
been a
like
lot of promise and hype and for decades, right? And
absolutely.
at this point, the new nuclear sector has to convince risk averse utilities and customers about profitability of projects and show that new nuclear technologies will be competitive sources of power and safe compared to renewable natural
Now
gas.
that said, from Obama to Biden to Trump, we have now seen a significant push on both the Democratic and Republican side to fold new nuclear into the energy mix. And so, from the White House to the Department of Energy to the Federal Energy Regulatory Commission, the FERC, there is now a kind of a pretty good alignment of support in theory. Doesn't mean that all the financial and regulatory hurdles are all worked out, but we are in a pro-nuclear regulatory environment, whereas 15 years ago we were not. And just to say, as a Californian, at one point the plan for California was to have a nuclear plant every 20 miles along the coast. When Jerry Brown was governor the first time in the 70s, when he was governor Moonbeam, dating Linda Ronstadt and various things. That was the point when California decided we will not build any new nuclear plants until we have a better waste solution, which we still don't have. So California, instead of having one every 20 miles along a 700-mile long coastline, California is down to one operating plant with the dubious name Diablo Canyon, Devil's Canyon, and it's a plant that was almost literally built backwards because someone flipped the plans. The prices are huge. Pacific Gas and Electric, the operating utility, is still paying a debt on it. And after many, many complicated back and forths, California agreed to extend the life of that plant to 2030, but absolutely no more.
Right. It's very interesting. Now, we've talked a lot, sort of danced around the fact that small modular reactors are very, very similar to technologies to the ones that nuclear power plants that you've seen, 9 Mile Point or Calvert Cliffs. But I want to get into talking to a nuclear engineer is a very good way to start this is tell me more about fusion, right? I have my friend Rick Needham, who's at Commonwealth Fusion. There's a lot of people with a lot of promise for fusion. Tell me more about what on earth is going on in the 2020s with fusion.
So just to be clear, as anyone who's going to write in who's pro-nuclear is going to say, well, Dan, you are not a nuclear engineer. You might be a professor of nuclear engineering, but you are a physicist and you think physics talk. So we are going to do a whole episodes on fusion, and full disclosure, I am part of a fusion company. So biases are clear. My company is called Alpha Ring. So in my view, in 2070, we are likely to see fusion as a dominant form of energy. Right now, there is only one facility on the planet that is doing what I'll call terrestrial fusion. It's in Lawrence Livermore National Laboratory. They have 196 lasers focused on a target the size of a pencil eraser. It's actually a little bit of fuel wrapped in gold foil. They have gotten that to fuse, and they are now getting 3 to 4 times more power out than they put in. It is not a prototype nuclear fusion reactor. It is a demonstration that we can do on the surface of the Earth what happens in the sun. But I believe, for a whole bunch of reasons, that by 2070, this will be a big part of our energy mix. And you will not find many people that agree with me on that.
And what you mean by that, and I hope that we put a whole bunch more information on our energymatters.world website, because there's fusion I find incredibly complicated. But tell us more about it, because what you're saying is that the world will be 70% powered by fusion in 2070, but half of that will be 93 million miles away.
Right. So my tagline is exactly that. So 93 million miles away, that's how far it is from Earth to the sun. So what I'm saying in nerd Star Trek speak is that I think that we have 0% of our electricity today from fusion. I think in 2070, it'll go from 0 to 35% roughly. And another 35%, call it a third and a third, another third will be from solar power from the sun. That's fusion, but it happens to be 93 million miles away. So fusion is actually the simplest form. It's just very difficult. What you have to do is you have to crush together two hydrogen atoms, hydrogen being the most common atom in the universe, molecule in the universe, or atom because it's just one. But you can do heavier versions. So deuterium and tritium, heavy water is a version that's easier to fuse than simple hydrogen. And so I think that we will be making a lot of progress here because we have more than 50 companies that are doing interesting stuff. And the old joke that fusion is 50 years away and it's been 50 years away for 50 years, meaning it's not making progress, that all changed in 2022 when the Lawrence Livermore Laboratory in California, 40 miles outside San Francisco, achieved fusion with a net positive gain, and they have been making steady progress, getting the gains up to 400%, so 4 times more energy out than in. And they're just progressing. The problem is they have to recharge their capacitors, their batteries, for a couple days to have enough energy to do another fusion shot. So they've got a long way to go to be a
okay, so back up for a second. I was going to say, so all of these new fusion companies, I mean, how far away are they from actually making energy that you or I could use?
Well, they'll all tell you different things, but you mentioned one, Commonwealth Fusion in Massachusetts. They have a huge amount of money from U.S. and Italian investors. They said that they would have their plant working in early 2026. They still may make that goal. There is a bigger version in Korea called K-Star. They have already achieved the highest temperature ever achieved on the surface of the Earth, which is a requirement for fusion. There is a very promising Chinese fusion plant. There is a joint European called ITER. There are a number of candidates to do not the 196 laser version in Livermore, but what is considered more traditional fusion called a magnetic bottle, a tokamak, where you basically have a magnetic field, kind of like in one of those Terminator movies. You adjust the field, You keep the plasma, which is the highly excited ionized atoms, in a magnetic bottle. And to me, that seems like the easiest version. And AI and machine learning have made this far more workable than 10 years ago, because you need fast reacting smart systems, and that's what AI is. So I actually think one of those plants, the German plant, the Cambridge plant, the South Korean, will likely achieve their fusion in 2026.
That's really interesting. Okay, and just to be really clear, what's happening with fusion is separate and apart from these small modular reactors, correct?
Totally right. So
Totally.
I debated
Okay,
a recent. I just debated former Secretary of Energy and Nobel laureate Steve Chu. I said I think we will have one or more of these fusion companies making power at a prototype, a pilot facility that is putting power onto the grid, whether it's just at a national lab or somewhere else. I think we'll have that within a decade. And he said, "Oh, Dan, you are just ridiculously optimistic, arrogantly optimistic, if you will. And I think it's going to be 20 or more years." I think I'm going to win that bet, but he thinks he's going to win that bet.
We'll see. We'll see. Okay.
And we'll come back to this in a future episode of Energy Matters.
All right. To learn more, go to energymatters.world. Thank you for listening.